Hello. In this short supplemental lesson, I'll show you how to complete exercise 2 from the Dijkstra workbook, and this might help you to understand better how the Dijkstra algorithm works. In this lesson, I'll go through a worked example of Dijkstra, specifically the Dijkstra worksheet exercise 2. Here's the map. You have to find a route from A to G. I expect that looks a bit familiar to you. The first thing that you do is to create a table. I actually already gave you the table, but that's the first thing that you do. And we need to store 4 items of data: the name of each node, how you can get to it, the total distance from the start, and the status column. We just use that to keep track of which is the current active node and which nodes we've done with. So the first thing that you would do is to fill in all the nodes, and node A is the start node, so we're not linking to it from anything, and the total distance from the start obviously is 0 because it is the start. So that's how we begin. The next thing we have to do is to look for all the nodes that you can get to from A, and that is B, C and D. So I've written A next to B, C and D. There's a link to them from A. And now fill in the distances: 2, 9 and 3. A is now finished, so I cross out the word active, and you could write the word done, or this time round I'm putting an X. It's just to remind me not to go back to that node. It's easy to remember when there's only one, but gradually as the table fills up, it's convenient to keep track of which nodes are done. Okay, so the next thing we have to do is to pick the next node. All we do is we look down the distance column and find the smallest number, which is clearly number 2. Node B becomes the new active node. Now we have to find where we can get to from B. We can get to node C, but the total distance from A via B to C is 10. Just a reminder how you work that out. You look at the distance of B, which is 2, and then we add the new value, the route from B to C, which is 8. So that gives us a total of 10. That's bigger than what we've got already, so we don't put it in the table. There's one other place that you can get to from B, and that's E. With a total distance of 6, B with a value of 2, add on 4, gives a total distance of 6. There's nowhere else you can get to from B, so B is now finished. Once again, we have to pick the next node. It can't be A or B because they are done. So looking at the remaining 3, we've got C at 9, D at 3 and E at 6. So it's clearly D that becomes the next active node. Looking at the table, we can get to F from D. That's the only other place we can get to. There's a route A to D. Obviously A is finished. The only other route is to F. So we can get to F from D, and the total distance is 5. 3, which is the distance to D, plus an extra 2. There are no other routes to F, so we write it into the table. That's it. D is now done. Okay, so now we find the next active node. C at 9, E at 6, F at 5. So it's clearly F becomes the next active node. Now, where can we get to from F? Obviously not back to D, we never go backwards. We can go forwards to G or forwards to C. So we can get to G from F at a total distance of, f has a distance of 5, add an extra 4, 9. So we found a route to the end node. It's a distance of 9. We can also get to node C, and the total distance to node C going via that route is 6. F is 5, it's only one more to get to C, so that gives us a value of 6, and that overwrites what's there already. We found a quicker route to C. And that's F done. Notice that I've crossed out C very clearly, and I'll leave that crossing out in place. This is what we need to do to show that we can do the algorithm. It shows that we've understood what we're supposed to be doing. And in a question like this, they'll almost always put in an example where you have to do some crossing out. That shows them that you haven't just worked out by eye the quickest route, but you've actually done the full algorithm. Okay, so now there are 3 nodes left that are still available, C, E and G. Notice that G is not the shortest, it's not the active node, so we're not sure that we've found the shortest route to G yet. I think some of you, when you were doing this, as soon as you found a route to G, you thought the algorithm was over, and perhaps I hadn't explained that clearly enough. We have to keep going until we've found the shortest route to G, and the best way to do that is to keep going until G is the active node. That is the node with the shortest route. Okay, so we've got the choice of C or E. In fact, in the algorithm, it would just choose one of those, possibly at random or possibly in alphabetical order. It doesn't actually matter. I'm going to choose C, let's say for alphabetical reasons. The algorithm won't go wrong if you went to E next, but we'll do C. So C becomes the next active node. Where can we get to from C? Well, we can get to G, and the total distance is 8, because C is 6, and add an extra 2, and that gives us a value of 8. So we've actually found a quicker route to the end node at this point. We can also get to E, but that's a total distance of 10, and the current value of E is 6, so we don't replace that. So C is now done. We're left with 2 remaining nodes, E and G. We'll just quickly finish the algorithm. E becomes the active node because it's got the lowest value of 6. But you can't get anywhere from E back to B or C, both of which are shut. So actually we can't do anything with node E, so that is done. That leaves us with the active node is the target node, and that's how we know that the algorithm is finished. So we've found our route from A to G. Let's think about how we work out that route. Now we've completed the table. We get to G from, look at the table, bottom row of the table, we get to G from C. Looking at row C, we get to C from F. We get to F from D, and we get from D to D from A, which was our start node. So our complete route is A, D, F, C, G, with a distance of 8. I think it's quite hard to spot that by eye, just by looking at this table, but using the algorithm takes us methodically through it and finds us the right route. So that's how we do Dijkstra. So there's a number of things to remember. Fill in the table methodically. Only replace roots if you found a quicker way of getting to a node. And only finish when the target node becomes the active node. I hope that helps you in the next Dijkstra exercise that we do. Bye for now.